How can we raise up a giant? How do we give birth to a jungle warrior? How do we craft an airplane to take us around the world? Designers seeking to answer this strange mix of questions all came up with the same answer: twin booms. From the legendary Lockheed Lightning, to the de Havilland Vampire, to the Fairchild pack plane, designers have turned to twin booms to meet some of the toughest challenges. Though their quirky looks raised some eyebrows, more often than not, the boomers of aviation proved to be works of genius. Even without its twin-tail booms, the Kalinin K-7 is arguably one of the oddest-looking aircraft ever constructed. Designed by Soviet World War I pilot Konstantin Kalinin, it was quite Frankenstein in appearance, with 7 engines bolted onto the wings and with 2 massive underwing pods. The pods housed the landing gear and were armed with machine gun turrets. It was a bold piece of engineering. The K-7's gigantic wings spread almost as far as B-52s, and it could carry 128 passengers, 150 fully armed paratroopers, or 21,000 pounds of bombs. Unfortunately for the Soviets, their pride in homemade products may have been their downfall. Kalinin had planned to use BMW engines, but a switch was made to Soviet AM-34 engines. They were badly underpowered, and a 7th pusher engine was added between the tail booms as a booster. The K-7's diminutive twin tail may have been chosen as a way of keeping total weight down. However, the twin booms turned out to be the K-7's Achilles heel. On its final flight, the tail boom began to shudder and fell to pieces. The flying giant went into a deadly dive. 14 passengers and 1 bystander on the ground were killed. It was a PR nightmare for the Soviets, who had bragged about the creation of a totally Soviet-made monster aircraft. The twin boom design also helped to get a flying shoe into the air. The BV-138 was a twin boom amphibian aircraft built by German manufacturer Blohm & Voss. Seaplanes have to deal with a problem known as sticking, or the tendency of the hull to stick to the water during takeoff. Certainly, the BV-138's trimotors and rocket pods would have partially alleviated this issue. However, the designers at Blohm & Voss went one step further. They decided to give their seaplane a high twin-boom tail. The tail sat well above the waterline, meaning there was less hull surface area to stick to the water during takeoff. The shoe-like appearance of the clipped tailless fuselage earned this aircraft the nickname of Der Fliegende Holzschutz, or the Flying Clog. At first, the shoe was a good fit for Germany. At the start of World War II, it was the main maritime patrol and naval reconnaissance aircraft of the Luftwaffe. Later versions were equipped with a dural hoop for minesweeping. Perhaps the most notable achievement of the BV-138 was that it was also able to outduel another legendary seaplane in a dogfight, the consolidated Catalina. Though the shoe was an old favorite in the Luftwaffe, it soon became unfashionable. With the arrival of Allied carriers and more advanced fighters, the other shoe dropped, and the BV-138 was outmatched and obsolete. Twin booms could also provide an aircraft with a $1 million view. The Abrams P-1 Explorer was designed by Talbert Adams specifically for aerial photography and mapping. The P-1's twin booms allowed Talbot to place the engine at the rear of the fuselage. This kept the camera free from oil and also improved forward visibility. The cockpit was pushed well ahead of the wings and was walled with framed plexiglass, giving the pilot and crew an unobstructed view of all ahead and below. Talbot continued to tinker with the design in the hopes that the plane might snare a buyer and become mass-produced. But when war arrived, all those plans were put on hold. In World War II, reconnaissance aircraft were just as vital to operations as bombers and fighters. They could gather tactical recon about the movements and defenses of enemy forces, assess bomb damage, and help pinpoint the positions of enemy targets in the battlefield. In 1937, Germany was looking for a 3-seat recon aircraft to help support ground operations. Arado offered up the AR-198, a conventional aircraft with windows in all directions to ensure good visibility. From Blom and Voss came Dr. Richard Vought's daring asymmetrical plane, the BV-141. Legendary Focke-Wulf designer Kurt Tank gambled on a twin-boom design when he conceived the FW-189. Like the Abrams Explorer, the aircraft's twin booms provided for a clearer view of operations below. A central crew gondola, walled with windows, and virtually sitting on top of the wings, offered an excellent view in all directions. Tank jeopardized the proposal by insisting on 2 engines rather than 1, but in the end, the FW-189 won the competition and officially became Germany's eye in the sky. In all, 864 aircraft were produced in factories in Czechoslovakia and occupied France. The aircraft was particularly effective on the Russian front, where it gained the nickname the Rama, or frame, for the rectangular shape formed by the wing, tailplane, and booms. Russian fighters more often than not found themselves firing through the frame and hitting nothing but air. The FW-189, though not the quickest of aircraft, could outturn Russian fighters and blast them from behind with its machine guns. Visibility was also a paramount feature for night fighters searching for prey in dark hostile skies. It's not so surprising that the Americans chose a twin-boom design when they hatched the P-61 Black Widow. In 1940, Britain was looking for a night fighter of its own. The Luftwaffe's bombers were tormenting London, sneaking in under the cover of darkness. The RAF needed a high-altitude aircraft that could stand guard over London through the night to repel these invaders. Experiments were already underway, with a new key piece of night fighter technology, AI, or airborne radar. Radar would make a fighter a deadly nocturnal predator, able to pick out enemy aircraft in pitch darkness. A cash-strapped Britain shared the secrets of radar to U.S. manufacturers in the hopes of earning back royalties. Radar was the missing ingredient designer Jack Northrop needed to set loose his own deadly spider. His P-61 Black Widow was in many ways reminiscent of the FW-189. Both had twin booms, twin engines, and a central gondola with an excellent view in all directions. It was America's first aircraft to be installed with radar from the start. Like a spider sensing vibrations in its web, the Black Widow could detect enemy aircraft with the help of the radar unit housed in its rounded, protruding nose. Unlike the FW-189, the Black Widow was designed to be a killer, and its twin-boom design made it a crack shot. Originally, Black Widow carried 4 belly-mounted 20mm forward-firing cannons. Placing the guns in the center line made for more accurate shooting. Some variants also included 4 remote-controlled 50mm machine guns. The Widow could essentially strike approaching enemy aircraft coming from any direction in the upper hemisphere. A byproduct of its gun placement was more room in the wings for fuel storage. This was a critical feature, as the P-61 was designed to loiter for hours at a time. Many innovative features were packed into the Black Widow's fuselage. When asked about the twin-boom arrangement, Gerald H. Balzer, a former Northrop engineer, said, "The configuration of an airplane depends on what you want to cram into it." The P-61 arrived a little late in the war to have a significant impact, but there were other twin-boom fighters in the air causing mayhem for their opponents, including the fork-tailed Devil. One of the great strengths of the twin-boom design is the ability to place guns in the nose of a fighter without penalty. In World War I, the riddle of firing through a propeller without blowing it to pieces was solved with the invention of interrupter gears. In World War II, although it would have been theoretically possible to incorporate this same technology in some of the single-prop fighters of the day, there were the problems of additional weight and interrupter gears slowing the rate of fire. Fighters like the Spitfire and Mustang placed their weapons on their wings to avoid this issue altogether. Their guns were angled so the bullets would converge at a set distance in front of the aircraft. This, however, created another problem. a pilot had to wait till an enemy aircraft was a perfect distance away to ensure a good hit. This added a level of complexity to an already frenetic dogfight, which could lead to fatal results in the hands of less skilled pilots. Fighter pilots flying twin-boomed aircraft like the P-38 did not have to worry about conversions.
The reason the P-38 was so awesome in its firepower is because the guns were in the nose. When you fired 450s and 120 and it went straight out. And all the other fighters in World War II, the guns are out in the wings. So the fire goes, and right here is the only place that has maximum impact. The P-38's maximum impact all the way.
The Fokker G1 was World War II's original twin-boom fighter. It first flew in 1937, but it did not see combat until May of 1940. Nicknamed Le Faucheur, or Reaper, it was designed to reap destruction. This twin-engine heavy fighter had a potent arsenal of weapons to clear enemy aircraft from the skies and gain air superiority. There were two 23mm cannons and up to 8 7.9mm machine guns in the nose. One machine gun was installed in a rear-facing turret to deal with any invaders sneaking up from behind. Dutch aircraft manufacturer Fokker received an order of 26 G1s from an enthusiastic Spanish Republican government, but the aircraft were never delivered. Though the Spanish paid for the Reapers, there was a Dutch embargo on the sale of military aircraft to Spain. Fokker, however, continued building the aircraft and issued a false press release that the fighters were for Finland. The G1s didn't see any combat until the Dutch were literally fighting for their lives. On the 10th of May 1940, Nazi Germany invaded the Netherlands. The Dutch threw everything they had at them, including 36 G1s built for the Dutch Air Force. The end result of the 5-day battle against powerhouse Germany was a foregone conclusion. The G1s that took part in the battle were able to smite back at the Germans, strafing infantry units and attacking transport aircraft, but it was not enough. Construction of the Spanish G1s continued at the Fokker plant, but for a new set of owners. The Spanish order went to the Luftwaffe, who used their brand new G1s as trainers. Perhaps the best-known example of a twin-boom fighter in World War II was Lockheed's P-38 Lightning. Though an odd sight at the time, it would prove a formidable fighter and earn the nickname of Fork-tailed Devil from the Germans. In 1937, the U.S. Army Air Corps was looking for a new aircraft and issued a tough set of specifications to the manufacturers of the day. They needed a twin-engine, high-altitude interceptor with a maximum speed of 360 miles per hour and the ability to climb to 20,000 feet in 6 minutes. The aircraft was also required to use Allison's V-1710 engines with turbo superchargers and preferably have tricycle landing gear. Legendary Lockheed designer Clarence Kelly Johnson was up for the challenge. He experimented with a number of twin-engine configurations, including placing pusher engines behind the fuselage. In the end, he settled on a twin-boom design, much like the G1 and the FW-189. The lengthy twin booms allowed him to fit Allison's bulky turbo supercharger into a slender aerodynamic housing. With supercharged engines and an aerodynamically efficient airframe, the P-38 became the first American aircraft to break 400 miles per hour. The twin-boom design was unusual for the time and did cause some trepidation for new pilots. There were stories circulating of pilots bailing out and getting decapitated by the props. However, as long as proper bailout procedures were followed, the Lightning was as safe as any other American aircraft in an emergency. Streaking out of the clouds, the Lightning could strike down its opponents with a deadly blow. All of the Lightning's firepower was concentrated in its nose, one 20mm cannon and 4 M2 Browning machine guns, and it had the advantage of pinpoint firing accuracy. The straight-shooting Lightning could consistently hit targets up to 1,000 yards away, sawing aircraft in half in a blaze of bullets. Top-scoring American aces Thomas Maguire and Richard Bong took full advantage of the P-38's precision, racking up 40 and 38 kills respectively against the armorless aircraft of Japan.
Dick Bong was fearless, absolutely fearless. He had one basic rule, and he's told me that on a number of occasions. He said, fly up their tail and blow them away. Don't start shooting a mile away. Run up on their tail, get right on their tail and let them have it. And that's the way he did it.
The P-38 Lightning and the Fokker G1 were not the only examples of twin-boom fighters in World War II. The Swedes, too, had their own homegrown Saab 21. The Saab 21 was a twin-boom pusher aircraft, just like the Abrams P-1 Explorer. By incorporating a pusher engine, the designers ensured a clearer field of view ahead, unobstructed by rotating prop blades. However, there were legitimate concerns the pilot could get sucked into the propeller blades during a bailout. Although Saab toyed with the idea of jettisoning the propeller in an emergency, they determined an ejector seat was the best solution to the problem. Versatile twin-boom aircraft wore a number of hats during World War II. They were not just excellent spy planes and fighters, they also made top-notch transports. The Gotha Go-242 was a transport glider built to replace the DFS-230. The 230 was limited, as it could carry 9 troops only in tight quarters, and they had to enter and exit via a small side door. The German Air Ministry, the RLM, was looking for a serious upgrade, something that could carry twice as many troops and equipment. Albert Calckert of Gotha was able to give the RLM everything they wanted when he designed the Go-242. The box-like fuselage of this high-wing monoplane ended in clamshell doors, through which 20 troops or a small vehicle could march or roll in. The high twin-tail booms made this door arrangement possible. The gliders were towed into the air by HE-111s or Ju-52s. By adding rocket pods, the Go-242 could be loaded with even more men or machines. It was a widely used aircraft. Over 1,500 were built. Some were even fitted with radial engines when they were converted into Go-244s. America too experimented with twin-boom transports and created their own flying boxcar. With its twin tails, high wing, and low-hung fuselage, Fairchild's C-82 packet plane was the same basic shape as the German Go-242 and 244. The C-82 was designed to replace conventional transports like the Douglas Dakota. Though a workhorse transport, loading wheeled vehicles like Jeeps into the DC-3 was not the most elegant operation, while the low-hung fuselage of the C-82 allowed vehicles to just roll in. Officially named the packet plane, it was aptly nicknamed the Flying Boxcar, as it had virtually the same capacity as a standard railroad car. The boxcar lost some steam early in its career. The aircraft just didn't have the power to lift heavy cargo. It also arrived late in the war, and only a few were in service by war's end. 223 were built, and some took part in the Berlin airlift. Though the C-82 was something of a disappointment for Fairchild, their packet plane would have a second life. The C-82 was modified into the much more capable C-119. The C-82's high cockpit was moved to the nose of the plane to create more room for cargo. As well, the airframe was strengthened, and more powerful engines were installed to increase the carrying capacity. Maximum takeoff weight ballooned from 54,000 to 74,000 pounds, and troop carrying capacity increased from 42 to 62. The C-82 had been nicknamed the Boxcar, but now with the beefier C-119, it was official. During the Korean conflict, the C-119 made a name for itself as a bridge builder. In late 1959, the Chinese PLA destroyed a key bridge between Koto-ri and Hungnam. 8 U.S. Air Force C-119s carried an entire bridge, piece by piece, to restore the escape route between the two cities. Each of the 8 bridge sections were 2,900 pounds and 16 feet long. In the 1950s, other aircraft manufacturers looked to capitalize on the same basic twin-boom design of the boxcar. In France, Nord Aviation produced the Nord Atlas, and in England, Armstrong Whitworth developed the AW660 Argosy. This was a 4-engine turboprop with the cargo space of a typical flatbed truck. Its pod and twin-boom structure earned it the nickname the Whistling Wheelbarrow. In both cases, each aircraft had large doors at the rear to accommodate bulky pieces of cargo. While Nord Atlas and Armstrong Whitworth were interested in these conventional transports, back at Fairchild there was an attempt to create an even better mousetrap. Their XC-120 packplane streamlined the whole transport process. Traditionally, cargo was unloaded from truck and reloaded onto aircraft box by box or crate by crate. But what if there was a universal container that could detach from a truck and reattach onto a flying vehicle, substantially shortening loading time? This was the premise behind the XC-120 packplane. Fairchild took the fuselage of a C-119B and sliced it below the flight deck. They wanted to fit a rolling detachable pod underneath, so they raised the fuselage a few feet higher by angling the wings upward. It wasn't possible to have a traditional nose wheel, so 2 mini landing gear sets were added forward of the main gear. The landing gear was adjustable, so pod loading could be expedited. In addition to carrying cargo, the packplane might carry a specialized mobile hospital pod, mobile buildings, or pods to transport paratroopers. It seemed an ingenious idea, but the U.S. military failed to show any real interest, and instead purchased more traditional transports. The whole idea behind the packplane was crated up and discarded. The 1950s saw the gradual decline and retirement of many of the dependable prop-powered warriors of World War II. The new generation of fighters was jet-powered. Though there were several successful jet fighters in World War II, it took time for this technology to mature. When British manufacturer de Havilland conjured up the Vampire, they chose a twin-boom design to mitigate some of the weaknesses of early jet engines. The Vampire was built around a single Halford H1 engine, nicknamed the Goblin. The engine had only 2,300 pounds of thrust, and de Havilland engineers did all that they could to make full use of the power available. The Vampire was an extremely lightweight plane, made of molded plywood and metal, and it had 2 slender tail booms. Designers chose a twin-boom design to keep the jet pipe as short as possible. If they had used a conventional single tail, the exhaust would have had to travel a few feet farther, leading to a loss of power. The Vampire didn't have the greatest range to begin with, but when fitted with the next generations of Goblin engines, it became a record setter. The aircraft was in fact the first jet to cross the Atlantic when, on the 14th of July 1948, 6 RAF Vampires of No. 54 Squadron RAF traveled from Stornoway, Scotland to Goose Bay, Canada, with stops in Iceland and Greenland. Buyers weren't scared away from buying the Vampire and Ghost combination. Over 3,000 were sold in various configurations to over 30 air forces worldwide. The designers at Saab decided to add some Goblin power of their own to one of their reliable prop designs. Rather than build a new jet fighter from scratch, they chose to retrofit their pusher Saab 21 with a Goblin 2 engine. Back at de Havilland, designers continued to improve on the success of the Vampire design. In 1949, de Havilland unveiled the Venom. Although there were some modifications, this was essentially a Vampire with a new engine, almost twice as powerful, the de Havilland Ghost. In 1951, de Havilland made a much more radical change to the Vampire's original design. They created a twin-boom, twin-engine aircraft with swept wings for the Fleet Air Arm. It was known as the Sea Vixen. The Vixen had a major upgrade in engine power. It used two Rolls-Royce Avon engines with 7,500 pounds of thrust each, enough power for it to reach sound-breaking speeds in a shallow dive. The Sea Vixen had a unique two-seat arrangement.
The pilot's point of view may be that it was all right as an airplane, but what did the observer think? He was in a coal hole on the right of the pilot, and he was completely enclosed in there. And he hadn't much idea of what was going on outside. I would think it was a most unpleasant experience to be an observer on a Sea Vixen.
The Vampire and Venom had both been adapted for carrier use, but the Vixen was a purpose-built carrier-based fleet defense fighter. The aircraft could carry a complement of missiles, rockets, or bombs, including nuclear weapons. In some models, additional fuel tanks could be stored in enlarged tailbooms, which jutted out of the top of the wings. The Sea Vixen proved a capable fleet defense fighter, which served the Royal Navy until the 1970s. However, it did have an unusually high accident rate.
Night landing, deck landing is never easy. But a big airplane like this, it had the sad fault that the ailerons became very ineffective at the low speeds at which deck landing are carried out. And this caused problems with lining up the aircraft with the center line of the carrier at night.
Twin-boom aircraft were built with a multitude of engine arrangements throughout aviation history. There were twin jets like the Sea Vixen, single jets, twin prop planes, and pusher planes, just to name a few. But in the 1960s, an aircraft appeared which tried something different. The Cessna Skymaster had a push-pull configuration. There was a prop in the aircraft's nose and another in the rear of the fuselage. Cessna chose this design as safety was the main selling point of the aircraft. It was an interim replacement for the O-1 Bird Dog. With a single-engine aircraft like the Bird Dog, there was always the danger that the one engine might fail in mid-flight. The Skymaster's second engine was a fail-safe. As well, with twin-engine aircraft in a side-by-side arrangement, there is the issue of yaw should one engine fail in flight or during takeoff. The centerline thrust of the push-pull configuration ensured that the Skymaster would not veer out of control in these situations. It was a successful aircraft with almost 3,000 produced for military and civilian use. When the U.S. became entangled in the Vietnam War in the 1960s, the O-2, the militarized version of the Skymaster, served as a forward air controller and light observation aircraft, marking targets for heavier fighters and bombers. The O-2's second engine was invaluable should one give out over hostile territory. However, the O-2 wasn't particularly fast with both engines turning. With one damaged, it was a sitting duck. The Skymaster would be succeeded by another twin-boom aircraft especially built for the rough-and-tumble action of Vietnam, the OV-10 Bronco. When W.H. Beckett and Colonel K.P. Rice of the U.S. Marine Corps conceived the Bronco, they wanted to create a close air support aircraft that could operate from jungle roads. Twin booms were vital to the concept. They were impressed by the shooting accuracy of twin-boom fighters like the P-38, and wanted to include a 106mm recoilless rifle along the center line. The tailplane had to be high up on the tail booms just to avoid the backblast. The enthusiastic duo built the fiberglass prototype in Rice's garage, but they had a hard time convincing the U.S. Armed Forces of the benefits of the Bronco. But with things heating up in Vietnam, a specification for a light armed reconnaissance aircraft, LARA, was given the green light by the Navy, Marines, and Air Force. They were looking for a light attack and observation plane to replace the O-1 and O-2, and the Bronco fit the bill. The production version of the Bronco was not quite what Beckett and Rice had envisioned. The Bronco had become a heavyweight warhorse. Over 2,000 pounds of extra electronics, an ejection seat, and a more rugged landing gear meant operation from dirt roads was out of the question. It also lost the recoilless rifle that Beckett and Rice had longed for. The new design wasn't left defenseless, however. It could carry up to 3 tons of external munitions and 4 M60C machine guns. With these alterations, the Bronco still became one of the top-notch counterinsurgency aircraft and remained so for the next 30 years. In Vietnam, the Bronco had a twin-boom stablemate which proved you can teach an old dog new tricks. The C-119 boxcar, which had made a name for itself in Korea building bridges, was tasked with a deadly new mission. In Vietnam, the flying boxcars were transformed into flying gunships. They had a major upgrade in firepower and other equipment to complete the transformation. The AC-119G Shadow was readied for battle with armor plate, 4 Gatling miniguns, infrared sensors, and flare launchers, while the AC-119K Stinger was upgraded with 2 GE M61 Vulcan 20mm cannons and 2 underwing turbojets adding 6,000 pounds of thrust. In 1986, a twin-boom design attempted a first in aviation, a non-stop trip around the world without refueling. Burt Rutan's Model 76 was extremely lightweight. The airframe weighed only 939 pounds. As there would be no pit stops along the way, every pound counted. The twin booms were essentially huge fuel reservoirs. There were additional tanks in the wings, fuselage, and the canards, and it took 7,000 pounds of fuel to fill them all up. The aircraft had 2 engines, one in the front and one in the rear. The front engine was fired up during takeoff and the early stages of the flight, when the Voyager was heavy with fuel, but it was switched off for the remainder of the voyage. On December 14, 1986, Dick Rutan and Gina Yeager set off from Edwards Air Force Base for a trip around the world. The Voyager had a bumpy start that morning. The wings, sagging with fuel, scraped against the runway during takeoff, but the damage was minimal. Though they had to circumnavigate some hostile weather and had a faulty fuel pump to contend with, the trip went largely as planned. Perhaps the cramped conditions and the stress of the situation were the greatest obstacles of all. After 9 days, 3 minutes, and 44 seconds, on December 23, 1986, the exhausted duo returned to where they had started. The Voyager and her crew were victorious. Their triumph was shared with thousands of cheering spectators and the press who beamed the Voyager's round-the-world trip around the globe. When twin-boom aircraft first appeared, they were an odd bird, but their eccentric designs proved to be a stroke of genius. Designers faced with tough specifications often turned to boomers for the answer. Whether mapping the globe, circling the globe, or leading the charge into battle, time after time, twin-boom aircraft demonstrated their worth. Where twin booms will next take us, we can only guess. The sky is no longer the limit.
Getting troops and equipment through the air and quickly on the ground and into combat. This was a challenge tackled in World War II with the use of gliders like the Waco. However, gliders were built to be expendable and could not be returned. They also had to rely on another powered aircraft for towing. A major problem for glider pilots was that they only had one chance at landing. This meant that they could not avoid obstacles unseen from the air, or even deliberate traps set by the enemy. Many glider troops never even got to battle. They simply perished in their vulnerable wooden hulls. Sometimes the means of arrival was even more deadly than the enemy, and this was equally the same for both sides. Early in the war, the Germans produced the Gotha 242. a fairly successful glider that used a twin-boom tail arrangement. The 242 could carry a useful payload, which would be quickly unloaded through a large rear door. Some of the Gothas were fitted with small French piston engines, which negated the need for a tow plane. However, the most important feature of the powered glider was that its pilot could choose exactly the best place to land without running out of height. It also meant that after unloading, the aircraft could quickly take off and return to its base for another mission. This is the U.S. Air Force's Fairchild C-123 Provider. Much like the Gotha 242, it was originally built as an unpowered assault glider. Then later, engines were added. However, the glider version was nothing like the wooden Wacos and Gothas used in World War II. This aircraft was big and made entirely out of metal, and was also heavily reinforced for crash landings. If American soldiers had to glide to war again, then their safety was going to be a major consideration. Only 2 of the giant glider versions were built prior to the whole unpowered flight program being abandoned. However, the motorized version did go into production, and over 300 were successfully deployed. The Provider was very robust and able to cope with short and primitive landing areas. However, it wasn't considered quite as expendable as a Waco, which could fly right into a battle scenario. Shortly after war's end, American designers and military experts discussed the lessons learned from the conflict, speculating that it might be possible to land equipment without an aircraft actually landing, or at least not stopping. This idea, and other novel concepts of aerial support for ground soldiers, soon earned strong encouragement from a very qualified source, in the form of General Jim Gavin, often called the Jumping General due to his insistence on parachuting with his men in the 82nd Airborne. Gavin was a larger-than-life general who understood the needs of airborne support, and later from a post in the Pentagon, championed the cause of the pod. However, the question still remained, would it even be possible for a powered aircraft to simply discharge its cargo on flyby? The Material Division at Wright-Patterson were given the task of finding some kind of device which could egress from a moving aircraft at a very low level. The concept of a pod began to evolve, totally self-contained and of sturdy construction. Test pods were built and vigorously tested. The main test involved pods being dropped from under the wings of a B-26 bomber, serving as a mother plane for the experiment. At first, the pods were released while the B-26 was still on the ground, taxiing at about 100 miles an hour. The results were mixed, but showed potential. However, when the pods were dropped from a mother plane in low-level flight, and out of range of propeller wash, the separation worked quite well. If these experiments could be translated into full-scale practice, then the opportunities could be limitless. The next problem was to find a suitable carrier aircraft, and here the Air Force looked to a Fairchild Provider stablemate, the C-119 boxcar. The boxcar had evolved from the Packet. Both aircraft employed the same twin boomtail configuration once used on the earlier German Gotha gliders. These were purpose-built heavy transport aircraft with powerful engines. A single C-119 was totally reconfigured at Fairchild's Hagersfield plant to convey a parasite pod from one destination to another. Evolving into the XC-120 pack plane, the lower half of the boxcar was completely removed and the landing gear converted from the traditional tricycle arrangement into a quad configuration, leaving a suitable clear space to accommodate the pod. To lift the enormous loads into the air, the pack plane was equipped with 2 Wasp 4360 engines, which were actually more powerful than those used on the B-29. The engines provided enough power to carry Fairchild's Giant at 250 miles an hour, fully loaded. The pack plane itself had a crew of 5, 2 pilots, an engineer, and 2 especially trained loadmasters. The crew would operate a totally self-contained power hoist to upload or download the pods, and each pod had its own set of wheels to facilitate towing. Connecting the plane to the pod was achieved via 4 special clasps located on the top of each pod. Although just as important, surrounding the outer edge of the pod was an inflatable seal, driven by compressed air. This was to ensure the airflow of the speeding plane did not separate its cargo. Each pod had a drive-through layout, allowing for loading at both ends, or cargo to be driven on at one side and off at the other. Either way, it was a capacious unit able to support 20,000 pounds of freight, or over 60 well-equipped troops. Alternately, the pod could be configured as an ambulance or a massive fuel tank. There were also plans for totally self-contained suites as workshops, headquarters, or even hospitals, all able to be delivered as complete standalone units. The pack plane, with its rapid collection and drop-off capability, provided awesome displays to the military and public alike, and possibly seemed to have had serious appeal as an acquisition to the military. And to some extent it may have, although not sufficient to gain a production contract. Only one of this remarkable aircraft was ever built, and then a few years later, it was scrapped. However, if General Gavin's pod concept didn't live up entirely to his expectations, then certainly his prediction for the need of a frontline support transport with very rapid offloading did. The conflict in Vietnam provided many such uses for Lockheed's remarkable C-130, and nowhere more so than in the battle for Khe Sanh. In 1968, the North Vietnamese laid siege to an American Marine base. The objective was on a plateau in the Khe Sanh Valley in South Vietnam. Over time, the NVA surrounded the base, cutting off all land communications. Coinciding with the North's Tet Offensive on Saigon, holding the Khe Sanh base became a critical political as well as military U.S. objective. The siege lasted for almost 3 months, and for much of that time, the only way in or out was by airlift, and this was mostly achieved under heavy enemy fire. The assault transport's time had really come. Only aircraft like the C-130 and the C-123 could survive the relentless touch-and-go tactics demanded by the situation in Khe Sanh, which required rear-door delivery, sometimes speeding on the runway and sometimes over it. The determined use of American assault transport under persistent enemy fire held the line. High-speed ejection of cargo, fast turnaround, and low-level parachute drops all played their role. The U.S. had exactly the right types of aircraft at the right time. Versatile, rugged, and purpose-built for need. Things may have been very different on that plateau in Southeast Asia, without the need having been defined by the experience of men like General Gavin. In truth, the pack plane would probably never have worked well in a frontline combat situation. The demands of sophisticated and careful handling on a quiet tarmac in Hagersfield, Maryland, is very different from the mayhem of a furious battle for a Marine base in the Khe Sanh Valley. But was the pod concept really so far off? Amongst General James Gavin's other predictions was the increased need to use helicopters in modern warfare. This is the Sikorsky S-64. The civilian version is known as the Sky Crane. The S-64 was extremely successful doing recovery work and reconstruction in Vietnam. However, they also had another application of delivering purpose-built modules designed for specific functions, such as field headquarters, workshops, and hospitals. Some even called them pods.
Of all the U.S. fighters during World War II, only one remained in production throughout the entire conflict: Lockheed's P-38, the Lightning. Thanks to its firepower, speed, and the reliability of its twin engines, this versatile and advanced design became one of America's most durable and valuable assets.
It was the best damn airplane ever built, as far as I am concerned. It was like flying a Cadillac automobile.
It was just an aviator's dream to fly in a P-38. It made the war in the Pacific.
We had very few planes that could keep up with the speed of the German planes or even the Japanese planes, so they needed something that would be able to be competitive.
In 1933, the newly restructured Lockheed Aircraft Company gambled its future on developing an advanced twin-engine aircraft it hoped would remain at the forefront of aviation for the next decade. To test the design, A scale model was built at the then staggering cost of $5,000 and sent to the University of Michigan for wind tunnel testing. During this process, Lockheed's executives met a young engineer named Kelly Johnson. His innovative aircraft design ideas so impressed the company that he was quickly hired. This marked the start of a brilliant partnership, helping Lockheed become one of the world's leading aviation companies. In 1933, the new project involved significant risks during uncertain times. Perhaps Lockheed's greatest advantage against failure lay in the human resource of its talented staff. Although the company was becoming increasingly automated, this was still an era when technicians saw themselves as craftsmen, and Lockheed's production teams embodied an old-school dedication with immense pride in their work. They also understood that the company's future depended on the success of the new multi-purpose twin-engine aircraft. For the model to succeed, it wasn't just a commercial airliner that was needed, but various types of military aircraft as well. From this basic model, several variants, including the well-known Hudson bomber, went into mass production. In some ways, global politics worked in Lockheed's favor. The rise of the Axis powers, especially Germany's rearmament, highlighted an emerging threat to world peace and underscored the need for expanding American air power. Soon, the U.S. Defense Department identified the need for a high-speed anti-bomber aircraft, but they set the specifications so high that few in the industry believed they could be met. Lockheed assigned the project to Kelly Johnson, who believed the required maximum speed of 360 miles per hour was attainable, but only by using an aircraft with the power of 2 engines. In fact, Johnson's design surpassed expectations, capable of reaching over 400 miles per hour. Normally, a twin-engine configuration would result in poor maneuverability, but Johnson countered this with a brilliant twin-boom design. This innovation secured a Defense Department contract in June 1937 to produce a single aircraft, the Model 22, at a fixed price of $163,000. Once again, Lockheed was taking a major risk. The prototype would end up costing 5 times that amount. However, this extra investment proved to be one of the company's best decisions. The Model 22 was officially designated as the P-38 fighter. With Europe on the brink of war, production of the aircraft remained highly secret. By January 1939, after minor modifications to the braking system, the new aircraft was ready for its first flight. On January 27, the first XP-38, precursor to nearly 10,000 fighters, took flight for the first time. Securing government funding for armaments was still politically sensitive, and the Army Air Force recognized the need for public support for the P-38. To garner this, they unveiled the project by announcing an attempt to break the Trans-America airspeed record. On February 11, 1939, the only P-38 in existence, with just 6 hours of flight time, embarked on its record-setting flight. Lieutenant Ben Kelsey was at the controls, with the American public and taxpayers watching closely. To cover the journey, Kelsey refueled at Amarillo and Brightfield before reaching Mitchell Field. These stops added about an hour to the total flight time, but the aircraft still completed the 2,490-mile trip in just 7 hours and 43 minutes, only slightly longer than Howard Hughes' previous record, which had been set in a specially designed plane carrying enough fuel for the entire trip. Unfortunately, during Kelsey's final approach to Mitchell Field, the aircraft struck a line of trees, crashed, and was destroyed. However, the plane's impressive speed convinced the Defense Department to immediately award Lockheed a contract for 13 YP-38s. The aircraft were to be equipped with a 37mm cannon and 4 machine guns, 2 30mm and 2 50mm, making it one of the most heavily armed fighters of its time. Within months, even more firepower was added, while interior design changes nearly doubled its ammunition capacity. Lockheed was now firmly in the fighter business, and the Burbank plant was restructured for mass production, resulting in approximately 30,000 minor design changes. Additional modifications were also required to reduce the buffeting and address a phenomenon known as compressibility, which caused the aircraft to vibrate during certain maneuvers, particularly when diving. The true solution to the compressibility issue wouldn't be discovered for several years, but these minor setbacks didn't slow the progress of what was considered the world's best interceptor. In September 1939, as Germany invaded Poland and plunged Europe into World War II, the Army Air Force ordered an additional 66 P-38s on the same day the first P-38 made its maiden flight. From the outset, protecting the pilot with armor was a top priority. Throughout its service, the P-38 underwent constant testing to enhance its resilience against enemy fire, with pilot safety being paramount. The plexiglass canopy and armor plating around the pilot were rigorously tested with gunfire. In June 1940, the British ordered 600 of these impressive aircraft, naming them the Lightning. However, due to the secrecy surrounding the vital superchargers, they were only provided with a less powerful engine and aircraft equipped with propellers that rotated in the same direction. This hybrid version proved underpowered and difficult to handle, and the British accepted only 3 before dubbing them castrated Lightnings and cancelling the order.
The British didn't like the airplane. And they'd been in conflict for quite a while, and they knew airplanes, and they didn't want that thing. And it was a real dog. It didn't have some turbo. It didn't fly high. All the props turned in the same direction.
However, the name Lightning remained with the aircraft throughout its career. The American model retained the key features, including counter-rotating propellers that provided stability to the twin engines. Behind the engine was the critical General Electric supercharger, which transformed average engines into powerful units. By late 1940, Lightnings were rolling off the production line. These aircraft were exceptionally powerful, boasting a high rate of climb, long range, and the safety of twin engines, making them popular with pilots. Unfortunately, the compressibility issue continued to limit high-speed performance.
The P-38 was having a problem, credibility problem. Pilots are aspiring pilots and heard some things that weren't very complimentary about the P-38. Now, as young cadets, 20, 21 years old, we really didn't know what compressibility was at the time, but that was one of those rumors that the P-38 was a dangerous airplane if it hit compressibility.
In the early 1940s, pilot training began in 2-seater, single-engine biplanes, which were much lower in power. The trainee pilot always had an instructor present, but when a young pilot first sat in the cockpit of a twin-engine Lightning, he was entirely on his own. This created significant challenges given the plane's immense power. To address this, an awkward attempt was made to add a second seat in the port boom cockpit. More effective, however, was the piggyback concept. The radio was removed from behind the pilot's seat, allowing the instructor or trainee to crouch there, ensuring that the first-time pilot didn't have to manage the Lightning's intimidating power alone. The Lightning also introduced several unique features, such as a spoked steering wheel in place of the traditional joystick and dual-engine related controls for turning. The tricycle undercarriage was another innovation that pilots favored, as it made takeoffs and landings much easier than the standard tailwheel design. Landings were particularly safer, as the Lightning could land at higher speeds without risking a stall. During training, pilots were taught to always wind up the side windows, as failing to do so would disrupt the airflow during takeoff, causing severe buffeting from the resulting turbulence. New crews often worried about the dangers of bailing out of the twin-boom P-38, fearing the rear elevator slab might act like a blade and strike them as they exited the aircraft. However, as this training film emphasizes, those concerns were unfounded.
Bailouts can be made either, 1, by turning the plane on its back and dropping out, or 2, by getting out the left window and sliding down the wing. Now don't stand on the wing to jump.
The quality of the training was soon put to the test. After the attack on Pearl Harbor, America entered the war, and peacetime pilots transitioned into combat roles. Due to its long range, the P-38 could be flown in stages across the Atlantic to Britain. A squadron was stationed in Iceland to protect the staging airfield and patrol sea routes, attempting to intercept German long-range reconnaissance planes that were attacking ships and guiding U-boats. Without radar, these efforts were typically unsuccessful. However, on August 15, 1942, a patrolling P-38 spotted a Focke-Wulf Condor, and Lieutenant Shanahan shot down the German plane within seconds, marking the Army Air Force's first victory against the Luftwaffe. Focke-Wulf also produced the stub-nosed FW-190, which is often regarded as the best dogfighter of the entire Second World War in Europe. Alongside the Messerschmitt 109s, these aircraft had a devastating impact on early 8th Air Force daylight bombing campaigns against Germany. Without fighter protection, the early B-17s were shot down in alarming numbers, and at one point, the entire strategic bombing campaign was at risk. It became clear that to continue long-range daylight bombing, long-range escorts would be necessary. The Lightning emerged as the obvious choice, and American fighter crews were eager to showcase the P-38's potential. However, those stationed in Britain were initially sent to support the more urgent North African campaign, delaying the development of the bomber escort program. Typically flying along P-47 Thunderbolts, Lightning pilots would receive briefings on fighter protection and coordinate with the 8th Air Force heavy bombers. Finally, Lightnings were set to engage the Luftwaffe on equal terms. The results of these early encounters were mixed. While the P-38 had impressive diving capabilities at high speeds, it was not as agile as the FW-190s at high-altitude engagements. Instead, the Lightning proved more effective at lower altitudes, where it could dive on German fighters as they climbed to attack B-17 bomber formations. A high-speed dive attack was effective for only one approach, but with the Lightning's heavy firepower, an accurate pilot could make it the best way to engage German fighters. In the skies over Europe, the Lightning earned the German nickname Fork-Tailed Devil. The 8th Air Force's fighter escort operations were largely successful, resulting in significantly fewer B-17s being lost to enemy fighters. Additionally, it became standard practice for American fighters returning from escort missions to strafe enemy ground targets. In this role, the P-38 became legendary. Its long-range and formidable armament made it a deadly ground attack aircraft. German airfields were prime targets, and American fighters employed the same tactics used by Germany against England during the Battle of Britain, attacking German aircraft where they were most vulnerable, on the ground. The combat experiences led to enhancements in later models of the P-38. This is a light G model, which featured an enlarged chin intake under each engine. Improvements were also made to the aircraft's armament, with the cannon and machine gun combinations often being varied to increase firepower. Additionally, the wing tank hardpoints were now being utilized to carry 500-pound bombs, proving that this aircraft, originally designed as an anti-bomber interceptor, could also effectively serve in ground attack roles. Flying low off the Californian coast, this late model P-38 tested a new weapons combination. The issue of compressibility, identified as the buildup of shock waves over the airframe at high speeds, was finally addressed. Special flaps fitted under the main spar were tested and eventually installed on all late J models and widely used L model. These flaps provided a nose-up attitude during dives, keeping the aircraft stable and manageable in various flight positions. With these improvements, Lockheed's powerful Lightning became a nearly perfect fighting plane. These L models, based in Italy, showcase the aircraft's capabilities. Like all Lightnings, their performance relied heavily on the General Electric supercharger. When an aircraft was scrapped for any reason, maintenance crews would salvage reusable parts, placing particular emphasis on the crucial supercharger. Even in a state of decay, this P-38 held value for the Allied war effort. Maintaining twin-engine aircraft was, understandably, more time-consuming than caring for their single-engine counterparts. The ground crew's dedication was as crucial to the success of operations as that of any pilot. This squadron was being prepared for a ground attack mission. The decision to carry either drop tanks or bombs depended on the specific requirements of the mission. In this case, long-range capability was necessary. For ground attack missions, 2 500-pound bombs would be more suitable. In reality, P-38s were capable of carrying much heavier bomb loads, and the F model could even deliver 2 torpedoes. However, it was the versatile 500-pound bomb that saw the most frequent use. Immediately following their briefing, crews would depart to fly their missions, embodying a mix of determination and camaraderie. Each man hoped that the mission would be no more than a routine hulling job, but they were all aware that it could be anything but that. Throughout World War II, pilots recorded their victories on the sides of their aircraft, serving as both a morale booster and an accolade. This practice, which originated during World War I, was common among the air forces of all combatant nations. Some pilots placed all their trust in their aircraft, while others relied on sentimental objects for luck. All personal effects that could fall into enemy hands had to be surrendered before takeoff, and until they returned, the mission was paramount. This remarkable footage, captured from a camera suspended beneath the wing of a P-38, provides a glimpse of what Army Air Force pilots experienced during a routine interdiction mission. Back at Burbank, the final stages of P-38 production were often carried out outdoors, taking advantage of the clear Californian weather. However, the main plant was anything but exposed. The Lockheed factory, like other production facilities on the West Coast, was considered a prime target for Japanese suicide attacks. Given the critical role of the Lightning in the war effort, the Defense Department went to extraordinary lengths to camouflage this essential facility. The main Burbank factory underwent an impressive transformation, with the entire roof designed to resemble a paddock with rolling hills and even fake farmhouses to mislead Japanese aerial attackers. The reconnaissance version of the P-38 had no armament whatsoever, as it was equipped with large cameras mounted in the nose and relied on its speed for protection as well as on its paintwork. Early in the war, the Army was approached by Mr. Samuel Cabot, who offered a paint that would make aircraft invisible at altitude. Initially, the idea was dismissed, but later, in collaboration with the Sherwin-Williams Paint Company, a product was developed that made the P-38 almost invisible when viewed from the ground. The haze blue camouflage proved to be a remarkable success, yet its usage has seldom been highlighted. However, pilots who flew reconnaissance Lightnings were well aware of its effectiveness. In this footage, one of the haze blue reconnaissance planes flies alongside the standard olive drab of the fighter. The P-38's role in photo reconnaissance, particularly in the Pacific, was arguably its most vital function. As soon as a plane landed, the camera pack would be unloaded and the film processed immediately, allowing tacticians to assess the situation without delay. Many of the war's most crucial decisions relied entirely on these photographs. Given the value of the intelligence gathered, the reconnaissance Lightnings likely saved more lives than any other piece of hardware in the conflict. An unusually colored P-38 named Yippee was the 5,000th aircraft off the production line. To celebrate this milestone, it was painted in a bright vermilion, with its personalized name emblazoned on the nose and across the underside of the wings. Despite the striking exterior, if you look closely, you can see that the interior still retained the conventional drab olive color. When Lockheed first submitted its proposal to the Defense Department, it never anticipated